Hello, welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer A, well done. If you want to hear my explanation of how I found the answer, please continue watching. So, the diagram shows the path of a proton being deflected by the nucleus of an atom. Point P is the position of the proton when it is closest to the nucleus. So we've got a proton, obviously a proton has a positive charge, obviously the nucleus has a positive charge. So that proton is moving at high speed and is being slowed down because it's being deflected by the positive charge of the nucleus. As the proton moves away, it's going to be repelled by the nucleus and therefore it's going to speed up. So what we can certainly say about its velocity is its velocity will be high at this point, it gets less and less and less and less. Its velocity will be at a minimum at point P because it will gradually speed up and accelerate again as it moves away from the nucleus. So let's look at these questions. Its rate of change of momentum is at a minimum at P. Well, let's have a look. Momentum, we normally give the letter P for momentum, is the mass times the velocity. So the change in momentum is going to be the mass multiplied by the change in velocity. Well, at this particular point, the force between the proton and the nucleus is going to be at its maximum. And we know that the force is proportional to the acceleration. So if it's the force at its maximum, the acceleration is going to be at a maximum. So it's going to have the largest change in velocity, therefore the greatest change in momentum. So its rate of change of momentum is at a minimum? No, absolutely not. Its rate of change of momentum is actually at the maximum at point P. So we're trying to find something that's not true, so we could just stop now. We'll look at the other possible answers and see why they are true. Its kinetic energy is at a minimum. Well, kinetic energy is a half multiplied by mass times velocity squared. Yeah, the velocity of P of the proton at this point is 0. So yes, the kinetic energy is at a minimum. The potential energy is at a maximum. Well, electrical potential is given by 1 over 4 pi epsilon squared multiplied by the charge. In this particular case, we'll be talking about the charge and the nucleus over the separation between the two charges. So yeah, the potential, and therefore the electrical potential energy, is actually at its maximum at this point because the distance, the separation between the two charges, the proton and the nucleus, is at a minimum. Its acceleration is at a maximum. Yeah, we've already established that its acceleration is proportional to the force, and the force is at its greatest when the proton and the nucleus are closest to each other. So that one's also true. Obviously, A is not true. If you found this video useful, please press the like button. Make any comments below, that'll be helpful, particularly if there's any questions you'd like me to go through. I hope you'll share this video and watch more in the series.